you to the Maths 1 component of BS degree program. Okay, so this is the very first class, right? I'm Samriddha and I will be taking the Math 1 course. I'm one of your instructors. Okay, so let me just give a brief about the live session. So there will be 2 instructor session per week. One will be the summary session. That means we will just summarize the topic briefly, summarize them week wise, and the second will be the open session. So in the open session, basically you can consider it as a doubt session. Okay, so just after the summary session, we will expect from you that you will solve the problem from your assignment question, and whatever doubt you have, just collect them and let us know about them in the open session. Okay, so those open session will be more interactive. And the second thing is, while writing, if you have any doubt, you just can unmute yourself and let me know about your doubt. Okay, like while taking the class, I may not be able to check the chat box, so don't write your doubt in the chat box. You just directly unmute yourself and ask me the doubt. Okay, anything do you want to ask? No.
So, ma'am, will this session be a summary one or for doubts?
Yeah, this will be the summary one. That means we will basically summarize the week 1 in this session. Okay, so whatever conceptual doubt you have, you can ask it. So how many of you have already seen the recorded lectures?
Ma'am, I haven't such like.
Sorry?
Ma'am, I have attended one live session, but I have not watched the recorded one.
Okay, so you have attended the live session in Maths 1?
Yes, ma'am. When I was in qualified level, but
Okay.
not all of them, just a few sessions.
Okay, fine. And what about others? Have you seen the recorded lectures? Week 1 content?
Yes, ma'am. I have seen that.
Okay, fine. So, okay, I will just summarize them and briefly just recall the concept. We will discuss about it. And whatever doubt you have, you can unmute yourself and let me know. Okay?
Yes, ma'am.
Okay. Can you see my screen? Is it visible to all of you?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am, it is.
So, let us first just recall what were the topics of week 1. So, we learned about the concept of sets, right? And then set operations, various set operations, right? Okay, then we go through the concept of relations. So there are 5 to 6 different kind of relations, and we will discuss about them. So types of relation. And then we will touch the concept of function. Just touch, okay? Okay, so let us start with set and set operations. So what was the definition of set? Those who have already seen the recorded lectures, can you tell me the definition of sets?
Can I
Yes,
speak, ma'am?
ma'am. As far as I have, studied from the lectures, so a set is just a collection of some defined objects.
Okay. What about others?
Ma'am, set is a collection of. Sorry.
You can speak.
Set is a collection of unique elements, right? which is not ordered,
Not
right?
particularly unique, I guess. Just it needs to be defined. It should be
Okay.
easier to just include.
Okay. I will just collect your answers, then I will describe the definition. And what about others, other than you two?
Okay. Ma'am, set is the collection of well-defined object which can be infinite.
Okay. Anything else?
There is in set there is no requirement of members to be uniformly match. I think so,
Okay.
as far as remember in the lecture set.
Okay. Okay. Anything else from anyone? No? Okay. So I will just first write down the definition of set and then I will explain. Okay. So set is nothing but it's not a collection of well-defined objects, it's a well-defined collection of objects. Okay. So the place of the word well-defined is very important. And why is it so? I will explain it. Okay. So a set is basically well-defined collection of objects. Okay. So I have seen, yeah.
What have you written after relations and types of relations?
This is functions. F.
Okay, ma'am.
Okay. Functions, or sometimes we can say it maps. Okay. So a set is a well-defined collection of objects. I have seen so many students to use the word well-defined in front of object, but if you just give a think about it, so objects, when we are saying objects, that means it is already well-defined, right? Objects is already well-defined. So why to use the word well-defined in front of object? We need, set is basically collection of objects, and that collection should be well-defined, right? That means we will use the word well-defined always in front of collection. That means the collection should be well-defined, not the objects. Objects are already well-defined. Okay. So for example, yeah. So what do we mean by the word well-defined? So for example, we can take, suppose in a class, just I'm picking 2% X and Y and giving them the task to collect the most intelligent persons in the class. Okay. So what do you think? The collection from the perspective of X will be same as the perspective of Y or not? What do you think?
No, it won't be.
It don't
Yes,
be, right?
everyone a perception regarding things.
Correct. That means the collection of all the intelligent persons in the class may not be same from X's point of view and from Y point of view, right? That means it may differ person to person. And the collection which may differ person to person is not a well-defined collection. Okay. So a well-defined collection is what will be same from the point of view of any person, anything in the world. Okay. So for example, if I give those two person X and Y the task to collect all the boys in the class, then the collection will be same from X's point of view and from Y's point of view also, right? Right?
Yes, ma'am.
Ma'am, basically the well-defined here means the universally acceptable, I think.
Yes, right. So the word, by the word well-defined collection, we are meaning the universally acceptable. So that means I can give the task to anybody in the world and I will finish with the same collection. That is the well-defined collection. Okay. So
Ma'am,
yeah,
we can say that the result will be the same. So
yes,
for
the
that,
result will be same. Doesn't matter
correct.
which way we are going through to come to the result, but the result should be the same. Okay. Is it clear, or do you have any doubt? Why we should use the word well defined in front of collection, not in front of object? Is it clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So all of you are fine with it, right? Then we can proceed. So it was the notion of sets. You have to always keep this thing in your mind that a set is a well-defined collection of objects. Okay. Now, what a subset is? Subset is basically a sub-collection of some set, right? That means we will collect some selective element from the set, and this will call the subset of that set, right?
Yes, ma'am.
Yeah. So subset is nothing but sub-collection. Sub-collection. Okay. Now let us go through some example. So throughout the course, we will work in a real line system. Okay. So the real number, set of a real number is a set. Okay. So this is the most important example of set of all real numbers. Okay. So let us start with natural numbers. So here, typically by natural number, we mean from 1 to infinity. But here we will follow the programming language and we will consider the set of a natural number as the whole number. That means from 0 to infinity. Okay.
Ma'am, for in case of real numbers set, if we do not consider, complex numbers, so the set of all real numbers should be the largest one, is it?
Yes. If I consider up to real number, then the set of all real number is the largest set. That means the mother set of all the subsets. Yes,
Yeah,
correct.
yeah.
So here we already know it, right? So the natural number is typically from 1 to infinity, that we all know. But here for this course, we will consider the set of all natural numbers from 0 to infinity. Okay, we will start our counting from 0. Then we have set of integers. What is set of integers? It's from minus infinity to plus infinity, right?
Yes, sir. Ma'am, when
Yeah.
0 was being included in the set of natural numbers, the professor also gave a good reason about it. That 0 can also be looked at as something, which we count nothing. So counting nothing will also be considered, a natural number. Something like that
Yes,
was
yes.
told.
So that means we can start the count from, like, if we don't have anything, we can say that there is 0 number of objects. That is also a natural thing. So that we can include 0 in the set of all natural number. Yes. Okay. Then we have set of all integers, right? Sorry, set of all rationals. So what was the definition?
Any number, which can be written in
Express.
P by Q form.
Correct. Where
Where P and Q are integers and Q should not be 0, must not be 0.
Yes. So if Q is 0, then some number by 0 is not a defined number. So Q must not be 0. And this P and Q are taking from the set of all integers. Right? So this is the set of all rationals. Okay. Then we have irrationals. So what are irrationals? Is basically the complement of rationals. Right? So that means if I extract the rationals number from the real number system, then we will find the irrationals, right? So it's nothing but R minus Q, right? Then we have the largest one, the real number, right? And in all the sets, we have the inclusion property, right? So the set of all natural number is a subset of set of all integer. The set of all integer is a subset of set of all rational. That means if I simply take q equals to 1, right? Then we will find the rationals, right? The integers, right? So the set of all integers is nothing but subset of set of all rationals. And the set of all rationals is subset of real number. And real number is what? Nothing but the union of rationals and irrationals. Is the relation clear?
Yes, ma'am.
Okay. So what do we mean by complement of a set?
Complement of a set is with respect to some larger set. Is the set of such elements which are not.
That larger set we will call as universal set. Okay.
Yes.
Yeah. Now you continue your definition. Yes, with respect to the universal set.
Yes, ma'am. With respect to some universal set, it will be the set of such elements which are not available in that set already.
Okay. That means we will extract those elements of that subset, right?
Can I say?
Yes.
Yeah, sure.
And basically complement of sets are the set which include the element excluded from the available set we have actually.
Yes, correct. That means in a mathematical language, if I say that we have a set U, which is our universal set, and suppose A is any subset of the universal set, then by A complement, we actually mean U minus A. And what is that minus mean? That means all the elements which are in U but not in A, right?
And basically it's not belong to A.
Yeah, it doesn't belongs to A. So this notation is set minus. And this notation means all elements
which are in U but not in A.
Yes, correct. Which are in U but not in A. Okay.
And as the word has been used here, complement, it is like which completes the given set. Is it?
Yeah. Can you repeat whatever you said?
As the word complement has been used, it looks like it means completing the given set by adding other set.
You can say it. So the complement is like yeah, you can say it in that way. Completing the universal set. If I just take the union with the set of all element in that particular set, you can think it in that way.
But if A set have all the elements and the remaining space in the universal set are empty, then it will not complete. Then set A is equal to will be equal to the universal set, na? If that were the case.
So no, whenever it is suppose empty, so if you take the union, it will be again completing the universal set, na? It will be completing the universal set upon taking the union with the set. That means what I'm saying is A union A complement will be always the universal set. If I take the union.
Yes, ma'am. I agree with that. But if A complement is the empty set.
Yes, then also we have that relation, right? Union some empty set is again the universal set, right?
Ma'am, I am asking that if we have complement of A is an empty set, then can we consider A equal to the universal set?
Yes, definitely. Is A complement is empty, means A will be what? Universal set minus A complement, right? And which is nothing but the universal set. So we have the relation A complement of complement is nothing but A, right?
A, yes.
Okay.
Yes, that's clear.
So we learned about the complement of a set and set minus. So we have some other operations too. One is union, set union. So if I have two different sets, A and B, sets, then union is denoted by U and defined by A union B means collection of all elements in A or in B, right? Collection of all elements which are either in A or B. Okay. So with the word or, we will always represent the operation union. Okay. That is what you have to keep in your mind, that with the word or, we will always represent the operation union, and with the word and, we will always represent the operation intersection. Okay. So A union B means actually collection of all the elements in A and in B, right? So we can also see it via the Venn diagram. So what is Venn diagram? So if I have the set, the pictorial representation of sets and set operations is nothing but the Venn diagram, right? So if I have, suppose this is our set A and this is our set B, okay? Then what is A union B? They are either in A or in B. That means basically all the elements which are in A or B. So we will collect all the elements from A and B, right? We will collect all the elements of A and all the elements of B. That means this shaded area is A union B, right?
And we consider union as the or in the mathematical logic, no?
Yes.
Means all the elements either in either of the A's or B's.
Yeah.
Okay.
Okay. So basically we will collect all the elements which are in A or in B. Okay. So the or word will always represent union, and means intersection. That is what we will keep in your mind. Okay. So if I just take an example, suppose A equals 1, 2, 3, B equals 2, 3, 4. So then what will be any A union B? What will be the set A union B?
It will be the 1, 2, 3, 4.
Correct. Correct. So basically, we will not repeat the the elements which are in intersection. We will take it one time. That is what I wanted to say. Yeah. Do you have anything to ask?
Ma'am, basically, set has the property to not repeat the element value.
Yes.
So if two sets are given and they have both the same elements, then we already consider one at a time, not consider both.
Yes. Yes. We can consider one element at most one number of times. Okay. So is it clear? The union thing? What do we mean by union of two sets?
Yes, ma'am.
Okay. And then we have set intersection, right? So set intersection, typically we denote it as A intersection B. And what does it mean? The element which are in both A and B, right? A and
Common
B.
elements, basically.
Yeah, the common elements, basically, right? So all elements which are in both A and B. That means the common elements in A and B. So if I represent this in Venn diagram, so it will be, suppose this is our A, suppose this is our B, then the intersection will be the common portion in A and B. That means this portion is the shaded portion is the A intersection B, right?
Yes, ma'am.
And in the same example, what will be A intersection B?
It will be,
It
ma'am,
will be 2 and 3.
2 and 3, right? Okay. So this is what we mean by set union, set minus, and set intersection. Okay. So the set minus thing also we can represent in terms of Venn diagram, right? So if I try to represent, suppose we have a set B, we have a set A. So we know that what do we mean by A minus B, right? So A minus B is nothing but the elements which are in A but not in B, right? Element,
Yes, ma'am.
Yeah, which are in A but not in B. That means what should be the portion to be shaded?
the
It's
portion which is of
Only A.
this portion, right?
Yes, ma'am.
Elements that are only available in A.
Yeah. So the shaded portion is the elements of A which are not in B, right?
Yes,
That
ma'am.
means we can also write it as A intersection what? A intersection B complement, right? Right?
Yes, ma'am. It will consider as only, ma'am. But if the elements of there are in the universal set there are multiple elements.
Yes.
So if elements rather than A, that will also consider.
No, that is what we took A intersection B complement, right? So the element which are in both A and B complement. Got it? Is it fine for all of you? How A minus B is actually A intersection B complement? Is it fine? Okay.
Yes,
So silence means.
Sorry, can you explain it again? Sorry.
Okay. So, so if I take, suppose this box is our universal set. Okay. And suppose this is our A and this is our B. Okay. Then what is B complement? B complement is this shaded portion, right?
Yes.
And what is A? Sorry. Yeah. What is A? A is this portion, right? Let me use another color. So this will be helpful. So A is this portion, right? So what is basically A intersection B complement? A intersection B complement. That means the portion which are shaded by both yellow and white line, right? Is it or not? The portion which is shaded by both yellow and white line, right?
Okay, ma'am.
Ma'am,
Okay.
but this will not consider the intersection, na?
Yes. So the
Because it's a
intersection,
complement of B.
yes. So A intersection B is not shaded with your white lines, right? So we will not consider the A intersection B portion. We will only consider this portion. Only this portion, right?
Yes, ma'am.
So this portion is A intersection B complement. And we have already seen this is nothing but A minus B. Is it clear? Is it clear now?
Yes. Yes.
Yes, ma'am.
Okay.
Ma'am, means in easy words, actually the A minus B means the B part is excluded.
Yes. And B plus B part is excluded means simply we are taking the intersection with B complement, right? That means the element which are not in B.
Yes, yes. Means common element between A and the elements which are not in B
Yes.
is actually A minus B.
Yes. Is it fine logically? Can you connect those things?
Ma'am, I have a doubt in that.
Yes.
Ma'am, you draw the universal set as a box and then draw the A set and B set, and there is an intersection between them.
Yes.
It's not compulsory it will happen in the question, but possibility. If there is an element in A, some elements, and some elements in B, okay?
Okay.
And some elements outside the A and B,
Okay.
then the A intersection B complement will be not only A. It will
A
also
inter-
consider the element outside the set A and B.
Okay.
So this case you
No, see, that when we're taking A intersection B means this portion should be common in both A and B complement. That means all the elements of A intersection B complement should be in A and should be in B complement. There is no
Okay.
element which are outside A.
Yes, I understand.
Okay. So
Yes,
A
yes.
intersection B complements is always a subset of A and is always a subset of B complement, right?
Yes. We only take elements that are common between
Yes.
A and the B complement.
B complement. That means
Basically,
those elements
only
are
A
already.
element.
Yes, correct. So those elements are already in A and B complement, right? This
No.
is the first condition. They should be present in both the set. Right?
Yes,
That is why
understood.
I am taking this in the intersection. Is it clear now?
Yes, ma'am.
Okay. Anything else? Any other doubt? No? Okay. Then we have some other properties. We have the cardinality. So let us first explain what a cardinality is. So cardinality of a set A, this is called the cardinality of the set A, and it means the number of element in the set A, right?
Ma'am,
Yes.
sorry, ma'am, I just missed the part where you elaborated on this complement, B complement part. So, just for a moment, ma'am, can you tell me how did you explain with respect to the universal set?
Okay. So here
I'm asking about minus B.
yeah, I got it. So here basically what I explained is the white shaded portion is nothing but B complement, right? That means the element which are in the universal set but not in B. All the elements outside B basically, right?
Yes.
And only yellow shaded portion is all the elements in A. Now, when we are taking
Yeah.
intersection, means the portion which is shaded by both the line yellow and white, right? So that portion is nothing but A minus B, right? So if I
Yeah.
think it logically, so A minus B means we are excluding the points from A which are in B. That means basically we are taking the points of A which are in B complement, right?
Hmm.
Is it? Isn't it?
Yes, ma'am.
So that means basically the intersection of A with B complement, right?
Yeah.
The elements which are both in some A and some B complement, that means the elements which are in the intersection of these two sets. This is what we mean. Okay?
Okay, ma'am.
Okay. Okay. So then we have the concept of cardinality. So cardinality of a set is nothing but the number of element in the set. So in this example, what is the cardinality of A is 3, right?
Yes, ma'am.
What is the cardinality A union B?
It is 2. Sorry, ma'am, 4.
Correct. And A intersection B is 2, right? So
Yes.
it is the easy concept. Number of element in a set is called the cardinality. So we have some results along with the cardinality. So cardinality, suppose we have two different sets, A and B, two sets. There are two sets. Then the cardinality of A union B is nothing but the cardinality of A plus the cardinality of B minus the cardinality of A intersection B. This is what result we have. Now we can prove the result with the help of the Venn diagram, right? So it is logically clear. If I use the Venn diagram, cardinality of AB is basically all the elements which are in A or in B, both, right? Right?
Cardinality of, ma'am, which?
Cardinality of A and B means the elements of A and B, right? A union B, right? So
Yes,
A
ma'am.
union B means we are collecting all the elements which are in A or in B, right?
Yes, ma'am.
Yes, ma'am.
Yeah. So what is cardinality of A? That means all the elements in A, right? So if I just shade all the elements in A, it will look like that, right? This is what we mean by all the elements of A, right? That means basically
Yes,
the
ma'am.
set A. Okay. So we know that all the elements in A union B means we have to cover all the elements in A and in B. So this is what our first step we have already done with the first step. Second is cardinality of B. That means we have to collect all the elements of B, right? So all the elements of B are basically the green shaded portion, right? That means the set B is the green shaded portion, right?
Yes, ma'am.
Basically, it's repeating
Yeah,
same elements.
correct. So in the intersection portion, we have both green and white shaded portion. That means the intersection portion we are taking twice, right? Right?
Yes,
Yes, ma'am.
But we want to collect all the elements in A union B means we will collect all the elements at most one time, that we already know, right? So we are counting this white and green shaded portion twice. That is why we have to subtract it one time.
Once. Yes, ma'am.
Right? So that is the reason why we are subtracting the cardinality of A intersection B once. Is it clear?
Yes, ma'am.
Any doubt from this portion?
Yes, ma'am. Could you please explain once more?
Okay. So A union B means basically all the elements either in A or in B, right? So if I just draw the picture of A union B, it will be simply this. That means we will take all the element one time, right? So here cardinality of A means we will collect all the elements of A. That means the white shaded portion, which is nothing but A, right? And cardinality of B means we will collect all the elements in B. That means the green shaded portion. Now we can see the intersection portion, A intersection B, this portion, which are shaded by both the color green and white, is basically we are counting this portion twice, right? That means we are repeating it. So this is not allowed in the union, right? In the union, we have to take the common element at most one time, right? That means here we are taking the intersection portion twice. So we have to exclude them one time, right?
Yes,
That is
ma'am.
what we are using minus A intersection B once. Is it clear now?
Yes,
sir.
ma'am.
Oh.
Yes, ma'am.
Okay, fine. So this is for 2 sets. Now we have the same result for 3 sets and even for n sets. We have the same result for n sets and we can prove them with the same logic. Okay. So if you are interested, you can prove them with the same logic. So I will write it for 3 sets. You can extend it up to n set, but no need to do that. If you are interested, you can do. But for this course, we don't need to do that. So up to 3 set is fine. Okay. So this is the same result for 3 sets. Is nothing but cardinality of A union B union C, where A, B, C are 3 different sets. So this is nothing but cardinality of A
Plus B and plus C.
Cardinality of
minus
C minus A intersection B minus A intersection B intersections A intersections.
this, right? And we can prove it with the same logic. We can draw the Venn diagram and we can prove it. Okay, so if anyone is interested, you can prove it. And this is the most important result. And this is the most important thing that you may have to use this even in the exam. Okay, this is important from the exam point of view also.
Ma'am, in case of 3 sets, I thought it should have looked like the same as it was with 2 sets, like first adding individually and then subtracting their intersection,
No, so
not these terms.
yeah, so here we have to consider all the cases, right? So we are subtracting the portion A intersection B, again B intersection C, again A intersection C. That means basically we are excluding this portion A intersection B intersection C 3 times. But we need that portion, right? That is why we have to add them. Okay. Okay. So first we
Yes,
do
ma'am.
them 3 times and then we subtract them 3 times. But we need that portion, right? That is why we have to add the intersection of all the sets. Okay. So if you want to be more clear with the logic, you just draw the Venn diagram and then try to see what is happening here. Okay.
Ma'am, can you explain this
Okay.
through the Venn diagram, please?
Okay. So suppose this is our A, this is our B, this is our C. Okay. So when we are taking A, that means A is this portion, right? Right? So the part of A is done. Now we will take B. So B is this portion, right? Right? Then we have to take C also. So C means this portion. Right? So now, if I just check A intersection B, so A intersection B is this portion, right?
Yes, ma'am.
Yeah. So when we are excluding A intersection B, basically A intersection B, we are counting twice. With this portion, we are counting thrice, right? So when we are excluding A intersection B, that means we are excluding the whole portion. We are also excluding A intersection B intersection C, right? Similarly, when we are excluding B intersection C, that means this portion. So again, we are excluding A intersection B intersection C along with the yellow and green shaded portion, right? Similarly, for A intersection C, we are doing the same thing. That means what? We are excluding A intersection B intersection C for 3 times, right? That means there is,
Yes, ma'am.
we are basically not counting the portion, right? We took them 3 times, we excluded them 3 times. That means the result is 0, right? We are not taking the portion, right?
Yes, ma'am.
Right? That means we have to take the portion also, right? So we have to add the elements which are in A intersection B intersection C 1 time. That is what we have to take, plus A intersection B intersection C. Cardinality of A intersection B intersection C. Is it clear now?
Yes, ma'am.
Okay. So all of you are okay with it, right?
Yes, ma'am.
Okay, fine. Okay, now we can go to the relations. Okay. So one more set operation we have, the Cartesian product. So suppose we have 2 sets A and B. So the Cartesian products of A and B is denoted as A cross B and is defined by the pairs A comma B, where A belongs to capital A and B belongs to capital B, right? Right? So this is called the Cartesian product of 2 sets A and B, right? Is it fine?
Partition product.
Okay. Now let me know what do we mean by relation. So what do you know? What is the definition of relation?
Ma'am, when elements of 2 sets are, related by some property or some characteristic, we relate them through some characteristics.
Like reflexive, symmetric, and transitive.
Okay, so these are the types of relations. So simply, yeah, we will relate element from a set to another element of set, and which is nothing but a subset of the Cartesian product of this set, right? So a relation from A to B is the R is nothing but the subset of A cross B. Okay. So every time whenever we will mention the word relation, we will take them as a subset of the Cartesian product A and B. Okay. So A and B means.
Ma'am, can you explain using this subset symbol? Sometimes we, underline this elongated C, which is used for symbol, subset symbol. So what does that mean in that case?
Okay, so this means a proper subset which cannot be equal to the set, and if I take this underline, that means it can be equal to the set. Okay.
Yeah.
So if I take only this, that means the proper subset. That means if I exclude the whole set, that means the set itself and the empty set, the remaining sets are called proper subsets. And if I include the empty set and the main set, then it will call the subset, and we denote it with this. Okay, so relation is basically a subset of A cross B. Okay, empty
Okay.
relation is also possible. If I take the empty set, this is called the empty relation. Okay, so if it is subset of A cross B, that means A, B type of pairs are there, right? In a set R, then that means the relation is basically a set where A comma B types of pair are there, and whenever A comma B is in the set R, what we will say? We will say that A is related to B. A is related to B, right?
Yeah.
Yes, ma'am.
Whenever A comma B belongs to R, is basically if and only if condition. This sign means if and only if. That means it is implies and implied by. Whenever A comma B belongs to R, we will say basically, we will say A is related to B. Okay, and vice versa. That means when A is related to B, then A comma B in R. Okay, so that is what we mean by relation. That is what a relation is. Okay.
Okay.
So what I just said,
So, ma'am,
yeah.
yeah, this symbol that you just told us, if and only if, it is like if A comma B is in R, then the
Then
this condition, and if this condition fulfills, then A comma B is in R.
Yes.
yeah,
Both ways.
if not, then it.
Yes. That means if under the relation R, A is related to B, then only we can say that A comma B is in R. And if A comma B is in the set R, that means A is related to B under the relation R. Okay.
Yes. ma'am.
Anything else you want to ask?
No, ma'am. Thank you. No, ma'am.
So as we define the relation as a subset of A cross B, so phi is a subset of A cross B, right? That means phi is also a relation, right? Phi is also a relation as it is a subset of A cross B, right? And this is called the empty relation. Okay.
Yeah.
Then we have another relation called identity relation. So do you know what do we mean by identity relation?
When the relation
Ma'am, if it is a relation where we get the same type of elements related to themselves.
A comma A belongs to R. Identity relation.
Correct. So, and the relation, the set is exactly that set, right? That means collection of exactly those elements. There cannot be extra element other than those pairs, right? So if I take A, identity relation on A is what? Collection of all pair A cross A such that A belongs to A, and it is exactly equals to the set, right?
Yeah.
So if I take an example, suppose A equals to some 1, 2, 3, then what is identity relation?
A is equal to A, we can, one of them might be.
What? Can you repeat?
It is like we can say A is equal to A. The condition we can put in here.
1, 1.
Yeah.
1, 2, 3.
2, 2.
2, 2, 3, 3.
This is the identity relation, right? And identity relation is actually unique, right? So there are no other identity relation. Identity relation means itself, the set itself, and this set is unique. If I add any other element, suppose 1, 2 in it, it will not be identity anymore then, right? Right?
Yes, ma'am.
So identity relation is a unique relation, and it is exactly the set 1, 1, 2, 2, 3, 3 for the set A equals 1, 2, 3. That means the definition, right? We will collect all the paired A comma A for all A in the set A, capital A, right? So this is what identity relation means. And the note is identity relation is unique.
Ma'am, we have to do this for all elements in the set.
Yes, we have to do this for all elements. If I just take 1, 1, this set, this is a relation, but it will not be identity relation. Okay? This is not identity. Identity relation means we have to take all the pairs A comma A.
Present in A, yes.
Yes, and there cannot be any other element other than those pairs. So identity element or identity relation is actually the unique one. Okay.
If ma'am, if it have a 5 element, then it will consider identity.
No. So what we mean by identity is exactly those collections. If I add, suppose we have the set 1, 1, 2, 2, 3, 3, and 1, 3. Then all the pairs are there, and along with them, I just added 1, 3, and it is not identity. Not identity.
It is some kind of relation, but not identity.
Yes, it is some kind of relation. It is relation. Definitely, it is a relation, but it is not identity. And what is the reason behind it?
That extra element 1, 3
yes.
is there.
Correct. That means identity. Yeah.
Ma'am, by unique, what you meant actually?
Unique means we cannot construct any other relation which is identity. We cannot construct any other identity relation.
Only one identity relation is possible on a given set.
Yes, only one identity relation is possible on a given set. Okay.
Basically, here is a domain. The elements of domain is equal to the elements of codomain.
Yes, here whenever we will say some relation on a set A means we are considering the relation from A to A. Okay.
Ma'am, A to A relation is also for the reflexive, but reflexive relation can include 1, 3. But in the identity relation, I think we only need the relation in which domain and the codomain elements are the same.
Yes. Yes. So in the identity relation, we have only those pairs. That means this is the identity relation, and this is unique. That means we cannot consider any construct any other identity relation on the set A. Right? So this set, for example, this set is not an identity relation. Now, if I come to reflexive relation, we have another relation, reflexive relation. So R is called reflexive relation if the identity relation is a subset of R. Is the definition clear? That means if R is a superset of the identity relation, superset means it will contain the identity relation, then we can say that it is a reflexive relation. Is it clear? The definition of reflexive relation?
Yes, ma'am.
Ma'am, please repeat once more, please.
Okay. So R, the set R will be called a reflexive relation if the identity relation I is a subset of R. That means we can also say it in different way that all the pairs A comma A, that all, it is if and only if condition, all the pairs A comma A should be there in the R for all A belongs to A. This is the definition of reflexive relation. And we can define it in different way, that the identity relation will be subset of R. That means all the pairs A comma A will be in the set R. Right?
Ma'am, so
Hmm.
I wanted to ask one question, that identity relation is proper subset of R or subset of R?
No, this is subset of R.
Means it can be equal to R as well.
Yes, it can be equal to R. That means if I take the identity relation itself, it is a reflexive relation, right? It is
Means all
satisfying.
identity are reflexive, but all reflexive are not identity.
Yes, correct. So
Like
the
the above
first,
example,
yes, like
1,
the
1,
above.
2, 2, 3, 3, and 1, 3, that one is reflexive.
Yes, this is reflexive. This
And
is reflexive, but
that
not
one is
identity.
not identity.
So identity relation is subset of R. We can also say it like all identity relation is a wrong word, because identity is a unique. So identity relation means reflexive, but
Oh.
not the converse one. That means a relation is identity means it will be automatically reflexive, but if a relation is reflexive, it may not be identity. Okay? Any doubt?
No,
Ma'am,
ma'am.
how come this 1 comma 3, this example is a reflexive relation? As per the definition you told, A comma A belongs to R for all A.
Isn't it satisfying for this?
This one condition, the first condition is satisfied, but the other
They are
one where
same,
it
they are
says
equivalent condition. First condition is satisfying means the second condition is also satisfying. A comma A is in R for all A in A, right? 1, 1, 2, 2, 3, 3. All the elements are in R, right? When we are saying reflexive, I never say that there won't be any other element other than those 3 pairs. There can be other elements which are not in the form A comma A in a reflexive relation. But all the elements A comma A for all A belongs to the set should be there. That means, if I say it in an easy word, the identity relation should be a subset of that relation if the relation is a reflexive relation.
Ma'am, can every identity relation can be a reflexive relation?
Yes, identity relation is always a reflexive relation. But reflexive relation may not be identity.
Yeah.
Okay?
Yes.
So this line can be written as another word, that identity relation is reflexive, but reflexive relation may not be identity. This is reflexive or not?
ma'am, yeah,
It is
that is
reflexive.
a problem.
It is
If the ordered pair
reflective, ma'am.
2 comma
It is
3,
reflective.
Yes, it is reflexive.
is reflexive, right?
How can 2, 3 come in this relation, in this set?
2, we are defining the relation in that way so that 2, 3 is there. But if the set is reflexive, that means A, A should be there for all A, and A, A is there for all A. Identity relation
So,
should be
yeah,
the
ma'am, now I
subset of
got
the
it.
relation, right?
Yeah,
Suppose
there
this
is
is
no
our
restriction in
R1.
adding other elements.
In identity relation, but this restriction is not there in case of reflexive relation. Okay.
Okay, ma'am. Yeah.
So I is subset of R1, right? Hence it is reflexive, right?
Yes, ma'am. We don't have to look at 2, 3.
Yes. We only need those 3 elements. Those elements which are in identity, this should be in the set. If identity relation is subset of that relation, that means it is reflexive. Okay.
Okay.
We will
Yes.
always check whether the identity relation is subset of that relation or not. Okay.
Yes, ma'am.
Is it reflexive?
No, ma'am.
No, ma'am.
No, ma'am. 3, 3 is missing.
Correct. This is not reflexive. Simple reason is I is not a subset of R2, right?
Yes, ma'am.
So this is not reflexive. So is it now clear what we mean by reflexive relation and what is the difference between identity relation and reflexive relation?
Yes, clear.
Is it clear for all of you?
Yes.
Yes, ma'am.
Yes.
Good. Okay. So maybe we can now go to symmetric relation. Now we have symmetric. So any one of you, what do we mean by symmetric relation? What is the definition of symmetric relation?
Mm-hmm.
If A
It is like, ma'am,
belongs to
if
B and B belongs
A comma B belongs to R and B comma A belongs to R. This is symmetric relation.
Okay.
Ma'am, if A comma B belongs to R, that implies that B comma A is also belongs to R.
Yes, correct.
then
Very
it is
good.
called symmetric.
Very good. So the definition is if. The word if is very important here. Okay. So if we have to keep in our mind. So if A comma B is there in the relation R, then it will imply that B comma A will be there in the relation R. Okay. For each A comma B in the set A. Okay.
Yeah.
That means if A comma B is there, then we will check for B comma A. But if A comma B is not there in the set, we will not check. That is why
Then-
this word if is important. If A comma B is there. If not,
If not, then it will
this is not
be
our point of
symmetric.
concern. Okay.
Yeah.
Got it? The importance of the word if is the highest here. If A comma B is there, then we will check for B comma A. But if not, that is not our point of concern. Okay? Okay. Let us come to R1 and R2 again. Is R1 symmetric?
R1. No, ma'am, because 3, 2 needs to be there.
Yes. This is not symmetric because 3, 2 is not there in the set R1, right?
Yeah,
What
ma'am.
about R2?
Yes, it is
Ma'am,
symmetric
it is symmetric.
It is symmetric, right?
because 1, 2 and 2, 1. both
1
are
is there. And no other A comma B is there, right?
Yeah, ma'am.
Other than 1, 2 and 2. So this is this is not reflexive, but this is symmetric, right?
Yeah, ma'am.
Now if I go to, okay. So if I go to the identity relation, I.
Yeah.
This is reflexive, right? Is it
Yeah.
symmetric?
No, ma'am.
Yeah, ma'am, it is. It is symmetric.
Yes, ma'am.
Yes.
And
This
it is not symmetric.
Why is it not symmetric? Whoever is telling it is not symmetric. What is the reason?
Yes, ma'am. Because
Because
ma'am, reverse is not there actually.
what reverse is not there?
Like
Can you
1,
find
2,
any?
2, 1.
Yes. So is 1, 2 is there?
Sir?
Do you can you see any 1, 2 in the set?
No, ma'am.
Then why will be concerned about 2, 1?
So I thought that it will
No.
not be.
No.
Till I could
So
not
if whatever I said is, if A, B is not there in the set, we will not look for B, A.
Yes.
Yeah.
If the word if is really important here. If A, B is there, then we will check for B, A. If A, B is not there, we will not check anything. We will directly conclude the set is symmetric.
Okay.
Because we don't have any example to contradict the definition. Okay.
Okay, ma'am.
So the main rule of mathematics is whenever we are saying that is this set is not that particular thing, that means there should be a element in the set which can be an example to contradict the definition of that something. Whenever, for example, whenever saying that this set is not symmetric, that means there should be an example in the set which can be an example to contradict the definition of symmetry. Is it clear? Or shall I repeat?
Yes, ma'am.
Clear.
Clear, right? That means in the set of all identity relation, we don't have any example which can contradict the definition of symmetry, right? Right?
Yes,
Can
ma'am.
you find any
So, ma'am,
example? Yes. Yeah.
identity relation will always be symmetric.
Correct. So if I don't have any example, means it will be automatically symmetric. What about this
Okay.
relation R?
It is also symmetric because no other element is there.
Correct. What about this relation?
Mm,
It is
no, ma'am.
not
One
symmetric.
Not
comma.
symmetric because 3, 1 is not there.
Correct. Because we have an example, right? 3, 1
Mm, yes.
doesn't belongs to the relation. So whenever we are saying that this set is not this or not that, that means we should have an example in our mind. If we don't have, we will not say. Okay. Is it clear now?
Yes, ma'am.
Yes.
Ma'am, could you please give one example of a relation which is both reflexive and symmetric?
The identity relation is both reflexive and symmetric, right? Now, if I take
Yes,
this relation, suppose 1, 1, our set is 1, 2, 3. Okay. 2, 2.
Okay.
So whenever we are saying it is reflexive, that means first of all, without give it a thing, we should include these 3 elements first, right? These 3 elements must be the part of a relation which is reflexive. Now we want it to be symmetric. So if I am taking any element in the way A, B, and we want the relation to be symmetric, means we have to take B, A. Right?
Right.
If I take another element 2, 3, then we have to take 3, 2, right? Otherwise, it will not be symmetric.
Symmetric.
So this is a relation which
Reflexive
is
as well as symmetric.
Reflexive and symmetric as well.
And if it have a pi element, then it will be symmetric or not.
which element?
Pi. Empathy.
No, it is not possible to include that.
5 element.
Yeah.
No, so we have to take the elements which are in A. right? 5 is not in A.
Okay.
Right? We have to take only the elements which are in A. We are considering the relations which are subset of A cross A, right?
Ma'am, I think he means 5, which is the empty set.
Okay, 5.
Yeah, ma'am.
5 is not an element. 5 is a set. 5 means there is no element in the set. 5 is not an element. Okay.
Okay.
5 is a set. And that means there is no element in the set. Okay.
Ma'am, can an empty set be any relation, or
Yes.
will not be any relation?
Empty set is called the empty relation.
Okay. So it is neither reflexive nor symmetric.
No. No. It's a
Not
trivial thing. Yes. Okay.
It has its own name, is it?
Yes. Okay. So is it
Yes, ma'am.
clear how the word if is the most important word in the definition of symmetric relation?
Yes, ma'am.
Yes, ma'am.
Okay, very good. Similarly, we have the transitive relation, and similarly the word if is important in the definition of transitive relation too. Similar type of concept we have to see in the transitive relation also. Okay. So what is the definition of transitive relation?
If
If
A is
A,
related
comma,
to the
B,
B, then C is also then B is also related to C.
no.
Okay. What
If
about
A,
other?
comma, B, if A, comma, B is in a relation R and B, comma, C is in R, then A, comma, C also relation in R.
Correct.
Yeah.
That means if A is related to B
Yes.
and B is related to C,
Yes.
that means A
Yes.
comma B and B comma C is in R, then it
Yes.
will imply that A comma C is in R, right?
R. Yes.
Yeah.
So here also the word if is important. That means if we can find this type of pattern A comma B and B comma C in the set R, then only we will think about A comma C. Otherwise we will not check. If we don't have this pattern A comma B and B comma C, here we have to check for two different elements. If we don't have this pattern, we will not check it. Okay.
Okay.
If A comma B is in the set, then
If A comma B is in the set and B comma C is not in the set, we will not.
Then it always be a transitive.
Yes, it will be automatically transitive. Okay. So for transitivity, we have to check for two elements. That means this pattern A comma B and B comma C, this is a pattern, right? We have to check for the pattern. If I find the pattern and if it doesn't imply that A comma C is in the set R, then we will say that it is not transitive. But if it is not the case, that means if we cannot find any such patterns, then we will automatically conclude that the set is transitive. Okay.
Couldn't get pardon, ma'am.
Yes. Please. You were asking something?
I have told that I couldn't get. Once
The
again.
definition.
Yes.
Okay. So the definition says if A comma B and B comma C is in the set R, then it should imply that A comma C is in the set R. That means whenever we will find those patterns, that means two element in such way, two element AB and BC, that means two element in the set in such way, AB and BC pattern, then we will check for the element AC. If AC is there in the set, we will say it is transitive for each element in A, and if there is an example such that ABBC belongs to R, but AC is not in R, we will say it is not transitive. But if I cannot find any such pattern, that means if there is no such pattern present in the set R, then we will automatically conclude the relation is transitive, because we don't have any example to contradict the definition. That is why we have to automatically conclude the relation is transitive. Is it clear now?
Yes, ma'am. If these two elements are there, then only we have to check. Otherwise, it will always be a
Otherwise-
transitive relation.
Yes, correct. So the word if is again very important here. If these two elements are there, then we will check for the next element. If not, it will be automatically transitive. That is what I meant to say. Is it fine?
Yes.
Yes, ma'am. Ma'am, is there something like this with symmetric relation?
Yeah, the symmetric relation is same, right? If AB is there, then we will check for BA. Otherwise, not. The same thing as symmetric.
Yeah, right.
So what do you think? This relation, the above example, is it transitive or not? Is it transitive or not? If you are saying it is not transitive, that means you have to give me an example.
And you are talking about R3.
R3, yes.
Ma'am, it is
It's not
transitive.
transitive.
The transitive.
1, 2, 1, 2, 3. It is transitive, ma'am.
Yeah, it is transitive, ma'am.
So all of you are saying it is transitive.
Ma'am, I was saying that it's not transitive actually.
No, I am also saying it's not transitive, ma'am.
Okay, and why?
Ma'am, because 1, comma 2 belongs to R, 2, comma 3 belongs to R, but 1, comma 3 does not belong to R.
Correct. Correct. So this is not transitive since we have the pattern ABBC 1, 2 and 2, 3, but 1, 3 is not in the set R.
Ma'am, how?
1, 2 and 2, 3 is there in the set R, right?
Yeah.
But
Oh,
can you
yes.
say 1, 3? No, right?
No, ma'am. Yes.
That means this is not transitive. That means we have a example. We have one example to contradict the definition of transitivity, right? Right?
Yeah, ma'am.
So whenever we have an example, we can say it is not that definition. Okay. So this is not transitive. Is it clear to all of you?
Yes, ma'am.
Yes, ma'am.
Okay. So let's move to another definition, another example. What about R2?
Ma'am, it is. There is no such example which contradicts transitivity.
Correct. It is transitive. So all of you agree with that? It is transitive?
Yeah, ma'am. This one is definitely transitive.
Yes. Correct. This is a transitive relation because we don't have any example to contradict the definition. Now, what about R1?
Ma'am, it is also transitive.
Yeah, ma'am.
R1 not transitive.
2, 3, then
Whoever
3,
is saying it is not transitive, can you come up with the example?
1,
Yeah, ma'am. It is not
2,
transitive.
3, but 1, 3
No,
not.
no, it is. It is, ma'am. It is transitive.
It is transitive, ma'am.
It is transitive.
All of you agree with it or not?
Yes,
Yeah, ma'am.
Transitive.
ma'am, I
is
don't agree that
transitive.
R1 is transitive actually.
Why? Then what? You should have an example, right?
Yes, ma'am. Because 1, 1 belongs to R, 2, 3 also belongs to R, but 1, 3 does not belong to R.
So do you think that 1, 1 and 2, 3 is in the pattern ABBC? It should be in the pattern
It needs to
ABBC.
start with 1, 3.
I'm sorry. Then 1, 2.
The second element of the
Then,
second.
1, 1 and 2, 2. 2, 3 does not belong to R. 2, 3 does not belong to R. 1, 1 and 2, 2, 3 does not belong to R. 1, 1 and 2, 2, 3 does not belong to R. 1, 1 and 2, 2, 3 does not belong to R. 1, 1 and 2, 2, 3 does not belong to R. 1, 1 and 2, 2, 3 does not belong to R. 1, 1 and 2, 2, 3 does not belong to R. 1, 1 and 2, 2, 3 does not belong to R. 1, 1 and 2, 2, 3 does not belong to R. 1, 1 and 2, 2, 3 does not belong to R. 1, 1 and 2, 2, 3 does not belong to R. 1, 1 and 2, 2, 3 does not belong to R. 1, 1 and 2, 2, 3 does not belong to R. 1, 1 and 2, 2, 3 does not belong to R. 1, 1 and 2,
The second element entry of some element should be same to the first entry of some element.
Okay.
Is it the case here? AB, then BC. That means the second entry of the element AB is same as the first entry of the element BC. Is it the case? Is there any element which are starting with 1?
No, ma'am.
No, ma'am.
So can you find any example?
No, ma'am.
Now, what do you think? Is it transitive or not?
Ma'am, it's transitive because
We don't have any example, right?
example to prove that, which
Correct.
contradicts.
Correct. So this is a transitive relation. So all of you are agree with it, right? This is a transitive relation.
Yes.
Any?
Yes, ma'am.
Okay. Okay. Fine. Okay. What about R? Suppose this is R4. So what about R4? Is it transitive?
Maybe it is also transitive.
Yes, transitive.
Yes,
Yes,
ma'am.
ma'am.
It is
It's transitive.
It is also transitive, right?
Yes,
So
ma'am.
this is also
If
transitive.
we look at the yes, ma'am. If you look at the last element 1, 3,
Then 3,
then
3
there
is
is
there.
3, 3.
But we need 1, 3.
And then again 1,
3
3
is correct. Very good.
again available there.
Yes. So this is a transitive. And what about R?
It is also transitive.
Yes,
We
ma'am. It's
don't need to
It is
check any.
transitive because no example to prove.
Both are transitive.
Correct. And what about I?
It is also
It is
transitive.
also.
It is also
It's
transitive.
also transitive, ma'am.
Yes, ma'am.
Transitive.
Right. Okay. So the definition of transitivity is then clear, right?
Yes, ma'am.
Now we have equivalence relation. What is equivalence relation?
Ma'am, relation in which they are
A relation which is
reflexive,
Which
both
is
symmetric,
transitive,
and
all the
reflexive, and
three,
transitive.
which satisfies all the three.
Correct. That means the relation
Reflexive,
which
symmetric,
are
yes, ma'am.
reflexive, symmetric, and transitive, right? This is called the equivalence relation.
Yes.
So R3, is it equivalence?
No.
No, ma'am.
It is
No,
not.
ma'am.
It is not transitive, right?
Because it was not transitive.
R2,
No.
No, ma'am, not reflexive.
No, ma'am.
correct. R1,
No,
No,
ma'am,
ma'am.
not
Not
symmetric.
symmetric.
R4,
No, ma'am.
Not symmetric.
not symmetric. R1,
Yes,
R1
ma'am.
is
Equivalence.
sorry,
equivalent.
R.
Yes, ma'am.
R equivalent.
Why?
Equivalent. Reflexive, symmetric, transitive.
Is it
Ma'am, it's
reflexive?
not reflexive.
So it is not equivalent, right? It is not reflexive.
Yeah, ma'am. It's not reflexive. Then
No,
it's
you
not
are asking
equivalent.
about identity, no?
No. R.
R. No,
Yes.
ma'am, it is not equivalence.
Yeah. And
It is not
identity is equivalence relation, right?
Yeah, ma'am.
That means we
Yes,
have the
yes.
corollary. Identity relation is a equivalent relation. Okay. So is it clear all the type of relation, their definition?
Yes, ma'am.
Okay, fine. Now whatever you have to do is to practice all the assignment question, and if you have some doubt, just collect them and just come up with the doubt in the next session. Okay. So these were the types of relations. There were the 5 type of relation. Yes. Yes. You are asking something? Someone was asking something.
Ma'am, I have a query.
Yes.
I have re-attempt qualifier in March.
Okay.
So I am student of my term. So is it necessary to give week 1 to 4 that quiz 1 again on 13 July?
Yes.
Repeatedly, ma'am.
Yes. Week 1 to 4 is there.
Okay.
Ma'am,
Yes.
ma'am, can you please explain me the difference between subset and proper subset? I'm a little bit confused in it.
Okay. So subset means empty set phi. Suppose we have the set A, S, and A is subset of S means A can be empty set and S also. But if I write this, that means A is proper subset of S. That means A cannot be phi, A cannot be S, but A can be any other set, any other subset of S other than phi and S.
Just want to mention this thing that A cannot be equal to its larger
And S.
set. Yeah, if we call
The
it
largest set
yes.
and the smallest set. So, largest subset and smallest.
Why, ma'am, do you write that A cannot be phi empty set? Why?
Proper subset means we don't include the empty set as a proper subset also. Okay.
Okay, ma'am. There is
Proper
one that,
subset means we will not include them, but these symbols typically means A is not equals to S. Okay. A should be, there should be at least one element in S which is not in A. Okay.
Yeah, yes, ma'am.
Okay. Now I will just briefly touch function. So what is function? Any one of you, can you
Special
just
type
explain
of
the definition?
relation.
Yes. Yes. Special type of relation.
And in such relations, it is like, ma'am, yeah, there are two conditions for a relation to become a function. First is, I guess, the element from the domain do not get paired twice.
Yes.
With the elements of the codomain.
Okay.
I think you are telling about one and two into many.
Okay. Let me just write the definition of function.
Ma'am,
So,
may I say once, please?
Yes, sure.
In simple language, means in a set where there is input and it will have at least one output, actually.
At least or at most?
Yes, ma'am?
At least one output?
Yes.
Is it possible to have two output for a element?
Not at least
exactly one, right? Unique.
Exactly one output.
Yes, correct. So the word unique is important here, right? And
Unique.
all the element of A, that means the domain, has an output. That means each element of the domain should be connected, should be related with some unique element in the codomain, right? Okay.
Every image has to have a pre-image.
No, every element should have an image. If every element has a pre-image, that means it is onto relation or onto mapping. Okay. So let me write the definition. So function.
Ma'am, excuse me. One boy, I think Duncan that all has one doubt. He raising hand.
Okay. Yeah. If you have doubt, you just unmute yourself and let me know your doubt.
I have a general doubt. Are you recording this session? Because I need to go. So can I access later?
Yeah, it is being live streaming in the YouTube.
Okay.
So you can go through it.
Okay, thank you.
Yeah. Okay. So a function, a relation F from A to B, from a set A to a set B is said to be function if each element of A is related to a unique element in B. So the word each element of A and unique element of B are the most two important word here, right? So each element of A should be related to an element of B, and that image should be unique. right?
Ma'am, can you teach me again, ma'am?
Okay. So the relation, first of all, it have to be a relation. That means it should be a subset of A cross B. Okay. So it can be said as a function if each element of A is related to a unique element of B. That means if I just draw the diagram, suppose we have 3 elements in the set A and 2 elements in the set B. So if I just take this, it will be a function or not?
No, ma'am, it's not.
Ma'am, no, ma'am, because third element is not related to B.
Correct. So this is what the importance of each element of A. So each element of A, we have to assign with some element of B, right? If not, that means if there is any element in A which is not assigned to an element of B, that means it is not a function. So this is not a function. But if I do the same thing,
It is not a function.
because this element has no image, right? Each element of A should be related to an element of B. But the third element, this is not related to any element of B. So this is basically contradicting the definition of function, right? Right? Agree?
Yes, ma'am.
Okay. Now similarly, if I draw this, is it a function?
No.
Yes. No, ma'am.
No, ma'am, it has
Yes.
two
Yes, ma'am, it's a function.
elements
The
have the
two
same.
elements of A having
It is
the
a
same
function.
element of B.
Yes, it is a function. That means each element of A is related to a unique element of is related to an element of B, and this is basically unique.
No, ma'am, it's not unique. They both have the same name.
No. By the word unique in B means the image of A should be unique. I mean, element, if
Yes,
I
ma'am.
do this,
Codomain
One-
should
like
be
if
unique.
a element from the domain is going to 2 different elements
that
of
will
domain,
not be a
that
function.
means it is not unique. But if one element is going to one element in the codomain, it is unique. This is not a function. If I draw this is not a function because this element is going towards 2 different elements in the codomain. This is not a function.
Ma'am, if the difference goes to the different element, it's not a transition, ma'am.
Okay, so in the case of function, 2 elements can go to 1 element, but 1 element cannot go to 2 different elements. 2 different element, what do we mean by unique element is 2 different element of A can go to a single element in B, but one single element in A cannot go to 2 different element in B. Okay, that is what we mean by the word unique. Okay. Okay. That
Yes,
means
ma'am.
one element, one element of A will map to exactly one element of B. It cannot map to 2 different elements of B. It is not allowed in case of function. But 2 different elements can go to the single element of B. It is a function. But it
can
is,
we map the same element, ma'am?
yes, it is allowed. In this example, we can see 2 different elements is going to a single element in the codomain, right? It is allowed in case of function, but this will not be one function. So whenever we have the concept of function, we have one function and onto function. Okay, so one function means mathematically f of x1, that means the image of x1 is equals to the image of x2. It means x1 is equals to x2. Or contrapositively, we can say if I have two element x1, x2, that means two different element from the domain, it will imply their images are different. Is the definition clear for one function? If I take two different element from the domain, their images will be different. Their images will be different. Then we will say that the function is 1, 1. Or contrapositively, we can say if the image of two elements are same, that means the two elements are nothing but the same. Okay.
And what is the difference between f of x1 and x1, ma'am?
x1 belongs to A. That means the domain. And f of x1 is the image of f. This is image of x1. And this is basically the member of D. That means the codomain. Okay. This is the domain.
Okay.
And this is the codomain. Okay. That means if the image of two elements same, then we can imply that the elements, those two elements are basically the same. And if contrapositively, the definition can be also described as if x1 is not equals to x2, that means if we take two different elements from A, then their images will be different. Is it clear?
Yes, ma'am, it's clear, ma'am.
Correct.
But the last slide, one thing I am not clear. Fx1 is image of x1, which belongs to B.
Yes. We are mapping.
A is domain and B is codomain.
B is codomain. Yes.
Understood.
Okay. So the image is member of.
But if we map the B to A, it is A is domain or codomain, ma'am?
So we have we have this A from A to B. That means A is domain and B is codomain here. Okay.
Okay, ma'am. We cannot map the different elements, ma'am.
What?
No, ma'am, we cannot map the different element, ma'am. B to A.
Yeah, we can define depend. If F is defined on B, then we can define. Not always. Like A is a general set, B is a general set. Okay.
Okay.
Yeah.
Ma'am, excuse me.
Yeah.
Ma'am, could you give one example of one function with Cartesian product?
Yes. So example, suppose we have A equals 1, 2, 3, B 1, 2. Suppose we are taking the relation is it a function?
No, ma'am.
No, ma'am.
Why?
The element 1 has two images in B.
Yeah. And also
The
2
element
and
with
3 has no
the-
image, right? So this is not a function.
Yes.
Not a function, ma'am.
Yeah.
Yes, ma'am.
It is also not mapped to any.
It's also not
Correct.
Ma'am, I didn't understand. Could you please elaborate it?
Is it a function?
Yes, ma'am.
No, ma'am.
Why? Why it is not a function?
Ma'am, it is a function.
It is
Every element of A is mapped to some element in B.
Yeah, and that
And-
element is unique, right?
And that element is unique. Yes.
Ma'am, can you explain? Ma'am, can you explain me this again, ma'am?
So we have 1 is mapping to 1, 2 is mapping to 2, and 3 is mapping to 1, right? That means one element we are assigned with one element only. So there is no problem. And each element we are assigning with some element, right?
Okay.
Ma'am, R1, can you please elaborate it?
For R1, 1 is going to 1 and 1 is going to 2. That means one single element is going to two different elements, right? This is the first
Ma'am,
reason.
between R1 and R2, ma'am, this one.
Huh?
No, ma'am. R1 and R2 difference, ma'am.
R1 and R2 difference.
Yes, ma'am.
Means you are saying R2 minus R1 or what?
R2 minus R1, ma'am.
Okay. So what will be the set R2 minus R1? What will be the set R2 minus R1?
Ma'am, it will be just leaving
2, comma 2,
1,
3,
1.
comma
3,
1, yeah.
3,
2, comma 2, 1, comma 2, and 3, comma 1.
1, comma 2 will not be there, right? R2 minus R1 means what? The elements which are in R2 but not in R1.
Not in R1.
Okay. So is it a function or not?
2,
No,
comma.
ma'am.
No, ma'am, because 1
All
is not
elements are
shared
not
to
shared.
any element.
1 has no image,
No
right?
image. Yes, ma'am. So, ma'am, element in B is known as image, right?
Yes. Yes. Element
Yeah.
in B is known as image. Now, R2 is a function, but is it a 1-1 function?
Ma'am, R1
No,
you
ma'am.
asked about.
R2. R2.
No, ma'am.
No,
No,
ma'am, it is not 1-1 because yeah,
1 and 3 are not same, but their images are same, right?
yes, ma'am. That two
Not
different elements
1.
of A has the same image. Have
Exactly.
the same
So
image.
we have 1 is not equals to 3, but f of 1 is equals to f of 3, right? F of 1 means the image, right? So this is not a 1-1 function. Now
Ma'am.
suppose, yes.
Ma'am, so can we say that the function will be 1-1 if the number of elements in both sets are equal?
In a way that the
Maybe, it
codomain
may
and
be.
domain are equal number of elements.
Maybe. We cannot confirm it. Okay. So suppose if I take 1, 2, 3 and B as 2, 3, 4, then the number of element in domain and codomain same, right? So we can define this function. This is a function, right?
Yes, ma'am.
1-1.
Sorry, let us define it in this way. This is a function, right?
Yes, ma'am.
But is it 1-1?
No.
So here the element in domain and in codomain is same, but still we can construct a function which is not 1-1. Okay. But if the cardinality of A is greater than the cardinality of B, then we can say that there exists no 1-1 function from A to B. This is a note. Okay.
Ma'am, this function,
The
why it
cardinality
is not
is the
1-1,
same.
ma'am?
Because 2 is going to 3, 3 is also going to 3, right? So 2 is not equal to 3, but their images are same, right?
Yeah, right.
But if cardinality of A is greater than cardinality of B, then there does not exist any 1-to-1 function from A to B, right? We need at least the number of elements which are in A, right? If I want to assign different element to different element in B, sorry, in A, right?
Ma'am, can you tell me again, ma'am?
Okay, so if I want to define 1-1 function, we need at the images, that means the number of element in B should be at least more than or at least equals to the number of element of A, right? At least equals to the number of element of A, right? Otherwise, we cannot assign each element of A to different number, right?
Ma'am, if B have a greater cardinality than A, then it will have 1, 1 or not.
If the cardinality of B is cardinality greater than the cardinality of A, that means this, then we can define some function which are 1, 1, but not all the function will be 1, 1. Okay.
Yeah.
Ma'am, can cardinality of B and cardinality of A can be equal, ma'am?
Yeah. In this example, cardinality B and cardinality of A is defined equal, right? So here also there are some functions which are not 1, 1, but we can define some function which are 1, 1. For example, if I take 1, 2, then 2, 3, then 3, 4. This is a 1, 1 function, right? From A to B, right?
Yes, ma'am.
Okay. So if I want to define the 1, 1 function from A to B, then the cardinality of A should be less equals to the cardinality of B. Okay. So if I see it by the Venn diagram, here the cardinality of B is, here the cardinality of B is less than the cardinality of A, right?
Yes, ma'am.
So can we define any 1, 1 function here? Is it possible? No, right?
No, ma'am.
No, ma'am.
That means this statement, if cardinality A is greater than the cardinality of the set B, then there does not exist any 1, 1 function from A to B. Okay.
And there will be a function, but not 1, 1.
Yes, there will be some function. It can be a function, but not 1, 1, right?
Yeah.
So if I want to define 1, 1 function from A to B, the necessary condition is the cardinality of B should be greater equals to the cardinality of the set A. Okay. Okay.
Understood.
Yes, ma'am.
Okay, good. Now we have the horizontal line test. Now, if I have a function, we can draw the graph of a function. So graph of a function in the Cartesian coordinate system will look like that. Okay. So horizontal line test is, if I draw some horizontal lines like that, and if it cuts the graph at 2 different points, then we will say the function is not 1, 1. But if it cuts the graph at exactly or at most at 1 point, then we will say that the function is 1, 1. So here in this example, we can see this horizontal line is basically, it cuts the graph at 2 different points. So this is not 1, 1, right?
How it is possible for the 1, 1 function in graph, ma'am?
Can you repeat? I didn't get.
How it is possible for the 1, 1 function in graph, ma'am?
Okay, so whenever we have function, we can draw the graph of the function, right? It is just the movement of this type of point, fx, x comma fx. So when I am drawing the graph of some function, that means this x-axis, this is the x-axis of the Cartesian coordinate system, right? This we can take as the domain. That means the point in this x-axis are basically nothing but the element of the domain. Okay.
Okay, ma'am.
And the y-axis is nothing but the codomain. Okay.
X is domain and the y-axis is codomain, ma'am.
Codomain. Yes.
Okay.
So suppose I have a element x here. Okay. And suppose this is the image of the element x in the codomain. Okay. That means the point x comma fx is what? This, right? Right? This point is x comma fx, right?
Yes, ma'am.
Okay. Similarly, for any point here in the domain, we have an image in the codomain, right?
Yes, ma'am.
That means for any x in the domain, we have fx. So we can find the pair x comma fx, right? Right? For any x in the domain. Now, if I just join the dots, it will look like a curve. And that curve is nothing but graph of the function. Okay. So the horizontal line test basically says, if I have, suppose this is a graph, and if a horizontal line cuts, if any horizontal line the cuts graph at two places, that means this is not 1, 1. So how can we prove it mathematically? If suppose this is our x1, can you mute yourself, whoever is muting yourself? Yeah. So suppose these are two different points, x1 and x2 in the domain. Okay. So this x1 and x2 are not same. It is clear, right? Right?
Ma'am, but it's for the horizontal line, ma'am. But if we draw the graph, a vertical line, how it is possible, ma'am?
Okay, I will come to that. See, so let me first explain why it is not 1, 1 if any horizontal line cuts the graph at two places. Okay, so if I take two different elements x1 and x2 in the domain, and their images are this, right? So this is f of x1 and this is also f of x2.
F of x2. Yes, sir.
That means we are taking two elements x1, x2 which are not same, but their images are same.
So it contradicts
So
the
it
definition.
is not 1, 1.
Correct. So that is why the horizontal, that is how the horizontal line test works. Is it clear now?
Yes, ma'am.
Yes,
Is this
sir.
many to one
If a horizontal line cuts a graph in 2 points, then it is not a 1, 1 function.
Yes, because then we will get the same image, right? If
Yes,
it
ma'am.
cuts
To
the
two
graph at
different or
more than 1 point. Okay.
So, ma'am,
or
can we say that every quadratic equation would not be 1, 1?
Yeah, it's depend upon the domain. We have to check. Okay. It depends upon the domain. Which domain we are taking.
Ma'am, so excuse me, is this many to one function?
Yes, is a many to one function. It is not 1, 1 function, means it is many to one function. Then we have the vertical line test for function. It is saying that if a vertical line cuts a graph or a curve in two like more than 1 points, then the graph will not be a graph of a function. That means if I have this, suppose if I draw any vertical line, it will cut this at two different places. Suppose this is our y-axis and this is our x-axis. Okay, that means this is the x-axis our domain and this is our codomain. Now for this graph, y-axis, we can say a vertical line, this is a vertical line and it cuts the graph fx at two different places. That means what? If I take this point, small x, this is a point in the domain, right? Right, this belongs to domain. The member of small x, the member of x-axis is domain. Now, for this point, this is an image. That means this is fx. This is also an image, right? This is also fx. But is it possible? Like one member of the domain is going to two different member of the codomain. Is it possible?
Then it is not a function.
Correct. So it is contradicting the definition of a function, right?
Yes, ma'am. It is not even a function.
Yes. Contradicting the definition of functions. That means this is the vertical line test. If I have any graph and if I draw a vertical line, if it cuts the graph at more than 1 point, then it will not be a function. Okay, this is what the horizontal and vertical line test. Is it clear? Like how it works mathematically?
Yes, ma'am.
Yes, ma'am.
Okay. Any doubt up to now?
And what is mean by contradicting function, ma'am?
Contradicting the definition of function.
Contradicting means not satisfying. Okay.
Okay, ma'am. Satisfied.
Not
Ma'am,
satisfying.
excuse me,
Okay.
could you please give an example of one-to-one function with Cartesian product?
Yes. So this is an example one function. This. If I take this set AB as 1, 2, 3 and 2, 3, 4, if I take this 1, 2, 2, 3 and 3, 4, it is a 1, 1 function. All the element is having the different images and they are unique. Is it fine? Is it okay?
Yes, ma'am. Ma'am, if suppose two elements are given,
Okay.
A cross B and B cross C, that relation
AB, BC. This or what?
ma'am, A cross B and B cross C. It's two Cartesian product.
Okay.
B cross C. So there we have to prove that whether it's one-to-one function.
No. So A cross B, if that means A cross B means what? All possible pairs are there, right?
Yes, sir.
So AB1, AB2 are there if B1 comma B2 belongs to B, right?
Yes, ma'am.
If there is more than one element in B, then this type of elements are there. That means one element in the domain is basically having two different images. But this is not, then this is contradicting the definition of the function, right? So this is not a function. Similarly, B comma C. Oh, is it fine? That is what you are asking, right? Right?
It would be better if you could once more make me understand.
Okay, so if I take the whole set A comma B, it is a relation, right?
Yes, ma'am.
But it is not a function because this type of pair will be there. Whenever we are saying A comma B, that means we are collecting all possible pairs
Yes, ma'am.
from A to B, right? So if there is more than one element in B, then we can construct A comma B1 and comma B2 such type of element in this set, right? A cross.
Can A cross B cross be similar to B?
What? You are not audible. Some network issue is there. Okay. So is it clear why A cross B will not be a function? It is a relation, but not a function. Okay.
Oh, ma'am, till now actually not clear. If you could make me understand once more.
Okay, so can you just tell me your doubt first? Like it was your doubt, right? That A cross B is a function or not?
Yes, ma'am.
So
Yes, ma'am, it's a function.
A cross B, suppose we have A equals A1, A2, for example, okay? And B is B1, B2, right?
Yes, ma'am.
Then what will be A cross B? A1, B1,
A1,
A2, B2, and A1, B2, and A2, B1.
This, right? This is the Cartesian product of A and B, right?
Yes, ma'am.
It is a relation, right?
Yes, ma'am.
Now you just say, is it a function?
Yes, ma'am, it is a function, ma'am.
Why?
No, ma'am, it is not a function.
Yes, the
No,
element.
ma'am, it's not function.
Yes, element A1 is going towards B1. Again, it is going towards B2.
B2.
Right? That means
It
one
has
element
two
is going
images.
towards two different images, and it is not allowed in case of functions. So not a function. Is it now clear?
Yes, ma'am.
Yes, ma'am.
I mean, is there any kind of example where A cross B Cartesian product, it will be a function?
Yes. If you take B as a singleton set, that means suppose A is A1, A2, and suppose we are taking B as singleton set B. Then what will be the Cartesian product of AB? This is A1,
A1, B, comma B,
A2,
A2, comma B.
right?
Yes, so then it will be a function.
Then it will be a function,
Okay.
right? So A cross B, it not necessarily a function, but in some particular cases, it may be a function.
Okay, ma'am.
For example, this, if B is singleton, then it may be a function, but not 1, 1. It can never be 1, 1 function, right?
Cartesian
Yes,
product can never be one function.
No. Yeah. Cartesian product can
Because
never be
unique elements, it's not unique with.
unique image we cannot consider.
Yes, ma'am.
Yes. Okay.
And ma'am, one more example could you give? Suppose A cross B is having relation with B cross C. Is related to B cross C.
Means what? I am not getting. What are you saying? You're taking the domain as A cross B.
Yes, ma'am.
Okay.
And
the codomain
ranges,
as B cross C.
yes, ma'am.
So this is a F from this. Okay.
Yes, ma'am. That way.
So
Exactly.
this is having A B such that A belongs to A, B belongs to B, this type of set, and this is having B comma C, where B belongs to B, C belongs to C, right? Now you can define any function like that. So just for example, if of AB we have to assign with some BC, right?
Yes.
So this B can be different. So okay, for example, we can define a function in such a way. Suppose this
B
is a
comma 0.
B comma 0. Suppose we are taking A, B and C as the singleton set 0. Okay. We can take anything else also, but let us take this because we are constructing an example. So we are taking C as singleton set 0. So this is one possible thing. Okay. Is it fine?
Yes, ma'am.
Okay. So you can take C as some different sets. You can find different function like that. Okay.
A comma B comma C is an empty set. No, it has element 0, so it's not empty set. It's,
yeah, it is not necessary that it is empty, but it can be empty, right?
Okay.
So we can also define relations from R cross R to R cross R.
Okay.
Right? Suppose some x comma y we are sending to x plus y comma y plus 1. This is a function from R cross R to R cross R, right?
Yes.
Right? So if x belongs to the real number, then x plus 1 will be again a member of reals, right?
Yes, ma'am.
Okay. So this is an example like that. So in this way, you can take any ABC and you can take any F. You can define any F in this way. Okay.
Ma'am, excuse me. Here, one part I am confused actually. In that part, if A comma B1, then is equal to then B comma 0. If there I suppose took B comma some other element, then would it be not a function?
B comma sir. Yes. It may be a function. It is just an example. It is just an example. Okay. Here I am taking C as 0. That means the second component can be 0 only. That is why I took this as a function.
And A and B is also 0?
No. A, B at some random set. Okay. And C is the singleton set 0. That means
0.
the element of B cross C will look like B comma 0 such that B belongs to B, right?
B belongs to B.
That is why I took this example.
Okay, ma'am.
Okay.
Example of a function where A cross B and B cross C are have relation, but it's not a function.
Yeah, there are several examples like that. So it can take like A comma B is a pair, suppose. Okay, suppose we have A1 B1 this and A1 B1 some A2 B2 with B comma C. Okay, so suppose I'm taking this two, so this will not be a function, right? Because this will be A1 B1 and this is A1 B1. So A1 B1, that means a pair from A cross B, it is going to B comma C. Again, A1 B1 is going to B1 comma C1. That means one element in A cross B is going to two different elements in B cross C, right?
Yes, sir.
So this is not a function. Same
Element that A1 comma B1, it's one element. It's going to.
It's a element of A cross B, right? And it's an element of B cross C, right? So this A1 B1 we are assigning with BC. Again, this A1 B1 we are assigning with B1 C1. That means one element from A cross B we are assigning with two different elements in B cross C. It is not allowed in the case of functions, right?
Yes, sir.
Yes. That means it is example of non-functional relation. Okay.
So exactly if I gist up this thing, that the functions part, that where function is not allowed, where for one domain there will be more than one codomain.
What? Can you repeat? More than one element in the codomain. One element in the domain cannot be related to more than one element in the codomain.
But the reverse can be true, that more than one element in the codomain can be.
Yes, the reverse is possible.
Two element in one element in domain.
Yes.
But more than one element.
One element from the domain cannot be related to more than one element in the codomain, but the reverse is possible. That means one element in the codomain can be related to more than one element in the domain, but it will not be one function in that case. But it can be a function.
Will be a function.
Yes.
Yes.
Okay. Now we have onto function. So onto function simply means all the element in the codomain will have a pre-image. Okay. Okay. That means all the element in the codomain should be associated with some element in the domain.
So the range is equal to codomain.
Correct. Simply, the range of the function is equals to codomain of the function. This is what
then the function becomes a codomain function.
Yes.
Oh, sorry, onto function.
Okay. So onto function means simply all the elements of the codomain should be related to some element in the domain. That means suppose we have this. Is it a onto function?
No, ma'am.
Because this is not having any pre-image, right?
Yes, ma'am. This is not associated to any image.
But if I take this, is it onto?
Yes, ma'am.
This is onto.
Yes, ma'am.
Okay. This is what we mean by onto function. That means we will start with any random element from the codomain and we have to check that whether there is any element in the domain for which the image of that element is basically that element in the codomain. That means any element in the codomain will have a pre-image. Okay. So that was the part in week 1. Now, if you have any other doubts, you can ask.
Ma'am, excuse me, that
again, same doubt. Suppose any Cartesian product can be onto function.
Any Cartesian product, first of all, it may not be a function.
Miss, I was just saying that I know that it may not be function. It's any example is there.
Yes,
Like,
yes. If I take B as singleton, that means this example. This is onto function, right?
yes,
This is
because
onto
range
function.
is equal to codomain.
Yes. So it is an example of onto function. So
But
Cartesian,
not a one-one function.
yeah, this is not 1, 1, but this is on.
Yes.
Okay. Anything else?
Ma'am, I had a doubt in activity question, so should I ask that?
No, if you have any doubt in your assignment question, we will pick them in the doubt session. Okay. So today, let us be
Okay,
more
ma'am.
focused on the concept. So
Okay.
problem related
Ma'am,
doubt, we will
in
pick in
the
next session. Yes.
okay, ma'am. So there was something the professor taught us in the set lectures. He said he gave an argument regarding how we get the result that power set of a set has 2 to the power n elements when that set has n elements. So he gave something like binary digit and then used that argument to prove this result. So can you elaborate on that thing? Like,
I don't actually remember what was the exact logic he gave for that.
I think he used the concept of combination or permutation.
Yes.
He said that
So if I have a set A, then power
and
set
it
of
has
A
elements
is,
and
suppose the cardinality of A is n, then the power set of A
yes,
is basically collection of
all subsets of A.
A, right? Okay.
Yes, ma'am. All.
And the cardinality, if the cardinality of A is n, then the cardinality of
P of A is 2 to the power n. So to prove that result, ma'am, Professor Madhavan gave an argument, which was
okay.
like
So
we
what
have
was
2
the
choices regarding average. When the argument goes like this, that we have 2 choices to include an element in our in a specific subset. The choice is either to include that element or to exclude that element.
Yes. So
So
for
because
each
of that
element
choices,
of the set A, we have two different choices, right? That is what he must have used. Like for each element, if I take any arbitrary subset of the set A, then for
yes, ma'am.
any element
Each
in A, we have two different choices, right? That means that element can be in the subset, it cannot be in the subset.
yes, ma'am. To make subsets of the set A, we have 2 choices to include an element.
Ma'am, pardon? Once again, could you repeat?
So suppose we have for say dot n, these are n elements of A. Okay. So suppose we want to construct all possible subset of A, then for each element of A, we have 2 choices, yes or no. Yes or no, right? That means in a particular subset, the element 1 can be in the set or it cannot be in the set, right? That means we have only 2 choices, yes or no, right?
Yes, ma'am.
So 2 choices for each element, and there are total n element. That means the total number of choices are 2 into 2 dot 2 n times, right? This is nothing but
Okay.
Okay. Ma'am, this idea has been used from combination or and permutation thing.
Yes. This is from combination and permutation and combination.
Ma'am, but why two choices are there, yes or no?
Because
Yeah.
one element of A can be in a set or it cannot be in a set. Either it will be in the set or it will not be in the set. We don't have any other choice other than that, right?
Ma'am, how it cannot be in the set 1, 2 to n, because all belongs to A.
Suppose,
So
no. Suppose if I
Subsets
take
of A.
this is a subset of A, right?
okay.
That means
Mm.
3, the element 3 is not there, but 1 is there in the set, right?
Okay.
Right? That is what I am saying. That one element, it can be in the set, that means a subset of the set A, or it cannot be in the subset. That means for each element, we have two different choices. That means the total number of choices is basically multiplication of 2 n times. That means 2 power n.
Okay, ma'am.
Okay, got it?
Understood, ma'am. Understood.
Okay. Yeah. Anything else?
Hello, ma'am.
Yeah.
Ma'am, do we have to give the quiz 1 or on June? It is on June, no?
Yes.
On 13th July.
So I
13th
am
July
in
or June?
foundational.
Ma'am, it is on 13th July.
Okay, I don't remember the
Okay.
exact date. You have to check it
Okay.
in the portal.
Ma'am, so I am in foundational level, so I have to give the quiz or not?
Yeah, you have to give the quiz, right? Whatever I know.
It is for
Yes, ma'am. I have
qualifier
also
or
heard that
foundation.
one will have to, even if you have cleared qualifier,
Yes.
again you will have to
Yes,
take
yes. You have
quiz
to give
1.
the quiz 1.
Okay.
Anything else you want to ask? If you have any doubt, you can ask. Otherwise, we can end.
Ma'am,
Ma'am,
so
I
Tuesday
think
session will be the topics or the concept set sessions, and the rest of the sessions are doubt clearing sessions, right, ma'am?
Yes. One will be the summary session. That means for the concepts, and one will be the open session. That means the problems.
So which means Tuesdays one will be the concept session.
Yes.
All
Yes.
Tuesdays.
Yes, all Tuesday will be the summary session, and all Saturday will be the open session.
Okay, ma'am. Thank you.
so all Tuesday will be concept session.
Yes, all Tuesday we will be summary session. Typically, I will take the summary session. Yeah. One more course instructor is there, and she will be taking the open session.
And doubt session is open session.
Yeah, yeah.
Ma'am,
Ma'am,
just for
could
my
you once
information.
scroll upwards?
Hello.
Yes.
I just wanted to know, ma'am, is it like instructor session or TA session?
How long?
Yeah. Can you repeat your doubt?
Yes, ma'am. I wanted to know, is it a TA session or an instructor session?
Okay, so
Like you
whatever
also
I
have
know,
TAs, right?
there will be 3 to 4 TA session and 2 instructor session. I'm talking about the instructor session. Okay, so the instructor session
Okay.
will be on Tuesday and Saturday. Okay.
What's the difference between TA session and instructor session?
Yeah, it's not normal, right? So instructor sessions mean instructors will be taking the session, and TA sessions means TAs will be taking the session. That's it.
Okay, ma'am.
Okay.
Okay. Yeah. Anything else?
Ma'am, could you once scroll up?
Yeah.
Yes. Here, ma'am. Their R cross R related to R cross R.
Yes.
That one will be 1-1 function or onto function.
This is both 1, 1 and onto function.
Ma'am, how?
So if I take any element xy in the codomain, any element xy in the codomain, the element x minus 1, y minus 1 will be pre-image of that element.
Yes. So it is a way, in a way, one-to-one function.
Yes. And 1, 1 means if x is not equals to y,
Yes.
then x plus 1 will be not equals to y plus 1, right?
Yes.
Sorry. If x1, y1, I don't have enough place. Let me write it here. So the function is x comma y, we're going to x plus 1 comma y plus 1, right? So if I take
Yes,
two
sir.
different elements, y2, we can imply that x comma x1 plus 1 comma y1 plus 1 is not equals to x2 plus 1 comma y2 plus 1. That means for different element in the domain, we have different images in the codomain, right?
Yes, ma'am.
That means it is 1, 1 and onto both. So it is a 1, 1 onto function. That means it is a bijective function. Anything else?
Well, here the onto part I couldn't understand.
Onto means what? For any element in the codomain, we should have a pre-image, right?
Yes, ma'am.
So now suppose if I take any element xy in the codomain, then
Yes,
the
ma'am.
pre-image will be x minus y minus y, right? The image of x minus y minus y is what? xy, right?
Yes, ma'am.
So the pre-image of xy is x minus 1, y minus 1, right? That means for any element, we can find the pre-image. That means it is,
Yes,
it is the
ma'am.
definition of onto function, right?
Yes, ma'am.
Ma'am, can a one move also be a onto function?
What? Can
a one function also be a onto function?
Yes, why not? This is an example of 1, 1 and onto function. This is an example which is both 1, 1 and onto. And if a function is both 1 and an onto, then we say that the function is a bijective function or invertible somehow.
And the injective is what?
Injective means 1, 1. Surjective means onto. And if both injective and surjective, then it is a bijective function.
Okay, ma'am.
Okay, ma'am.
Okay. Anything else?
Can we take a leave?
Yeah.
Thank you, ma'am.
Okay. So if you don't have any doubt, we can end the session here.
Ma'am, will recording be available?
Yes, it is being YouTube streaming. You can go to the live and you can see main channel item is here.
Okay, ma'am.
Okay,
Ma'am,
ma'am.
by the way, where are you from, ma'am?
I'm
Which
from
state?
West Bengal.
Ma'am, me too.
Okay, that's good.
Okay, ma'am. Thank you, ma'am.
Yeah. Okay. So welcome to all of you.
Yes,
All
ma'am.
the best for your journey and
Ma'am?
yeah. Yes.
Ma'am, are you pursuing PhD, ma'am?
No. I completed my master's last year from IIT Madras itself.
Ma'am, is this all the concepts for week 1?
Yes.
Or is it? Okay, thank you, ma'am.
Okay. So I am ending this session. Okay. Do you have anything
you, ma'am.
else to ask? Yeah. Welcome.
Thank you, ma'am.
Yeah. Welcome. Welcome all of you.